Hello and welcome to the presentation on Chapter 5 of the International Levee Handbook. I am Remy Tourment from Irstea in France, and I was the lead author for this chapter of the handbook. I was assisted in this task by Michael Wallis from HR Wallingford in the UK and Chris Newts from the United States Corps of Engineers. Many other individuals contributed to some extent to this chapter. In this short presentation, I will try to give you just a flavor of the content of the chapter by way of an introduction to some of its aspects. As you can see from the overall handbook summary, Chapter 5, called Levee Inspection, Assessment and Risk Attribution, is part of the Managing Levees group of chapters of the ILH. That is because the activities which are the object of Chapter 5 are conducted on existing levees, and they are conducted on a regular basis all along the levee life cycle. These activities are the link between the actions of levee managers and those of qualified engineers. In order to give decision-making to managers, they use the engineers' activities described in the toolbox part of the handbook. They also inform engineers in charge of the making changes part when these changes concern existing levee systems. Chapter 5 of the International Levee Handbooks details the principles for the levee assessment-related activities, including performance assessment, diagnosis, inspections, risk analysis, risk attribution. It also details the various sources of the data used in these activities: investigations, monitoring, visual surveys, and historical data. This chapter also outlines the principles of levee data management. This chapter is rather conceptual. Many activities presented in it are conducted in quite different ways in different countries or situations. The way they are presented in the ILH is probably the first attempt at a consistent and comprehensive framework of this topic. If you are not familiar with the concepts of flood risk management and the management of flood defenses, then I would strongly advise you to read Chapter 2 for the first basic introduction before progressing to this chapter. Chapter 3 is also very important as it presents important issues related to functions and failure, the basis of assessment and risk analysis activities. The Chapter 5 of the International Levee Handbook is a central chapter in the handbook for existing levee systems. It links levee management, including inspection, maintenance, and decision-making, with engineering, including performance assessment, risk analysis, and designing changes. In order to be certain at all times of the performance level of a levee system, it is necessary to conduct assessments as part of the regular management cycle. Assessments are also necessary in terms of decision-making for levee managers and funders. Such decision-making, for example, may include whether to stay inside the regular inspection and maintenance cycle, or investigate further assessments, or initiate the designing changes, or initiate maintenance actions, or undertake emergency actions. For the designer, these assessments also provide necessary information when designing changes for the improvement of existing levee systems. Section 5.1 of the International Levee Handbook is about the general concepts related to assessments, including consistent definitions and a framework for the different types of activities, which are detailed in the following sections, and include risk analysis and risk attribution, performance assessments and diagnosis, inspections, and their use in decision-making. Data is a crucial subject in terms of conducting an assessment, and the terminology about different data acquisition types is presented in this section. Although it is part of this section, decision-making is presented in the last slide of this presentation. The first section also presents the links between the different sections of Chapter 5 themselves, and also the links between Chapter 5 sections with other chapters of the handbooks. These are presented in this diagram. These links are different in nature. They can represent the use of a methodology. For example, section 5.3 makes use of methods described in Chapter 8 as denoted by green arrows. These links can also be the initiation of a process. For example, performance assessment, which I detailed in section 5.3, or risk analysis in section 5.2, can instigate the design of remediation measures, which are a Chapter 9 issue, as denoted by yellow arrows. Red arrows, in turn, denote a flow of data, such as the results of inspections, subject of 5.4 here, which are used by performance assessments, subject of 5.3. Risk-based approaches are becoming more common in terms of objectives. Priority in terms of decision-making is based on risk instead of being based on just performance of the production. In terms of methods, risk-based approaches still need development, common framework for methods, and specific researches. Section 5.2 is about the flood risk analysis and subsequent activities like risk attribution and evaluation of levee systems. Flood risk analysis identifies the combination of the probabilities and consequences of flooding and is conducted in order to explicitly evaluate the level of risk if no action is taken to mitigate those risks, to identify the monetary and non-monetary costs and benefits of mitigation options for reducing flood risk, to account for uncertainty and variability in possible outcomes to better inform decision-making. This section details the various important subjects related to flood risk analysis. The tiered approach can be adopted to flood risk management, in which the outcomes of an initial risk analysis is used to justify further action or inaction. Tiered risk analysis of levee systems is not necessarily a set of distinct levels. Rather, it is a progression from the simpler approach to the more complex, depending on the requirements and level of risk. A phased approach can be used for reduction of uncertainty in the data to be used in the risk analysis. When appropriately detailed or accurate data is not available, then surveys, studies, or measurements may be undertaken to obtain additional data and information of the required quality and coverage. For example, where information about levee materials is required, desk study and simple sampling and testing may be used initially, but may be followed by subsequent use of more detailed investigation methods. Other important concepts, knowledge gaps and uncertainties, different components of flood risk analysis, risk attribution and evaluation, additional components are all explained in the next slide. Flood risk analysis of levee systems include all components of the source pathway receptor model and not only the levee, in order to understand the nature and value of residual flood risk in a levee area. This diagram is very important and even essential for describing what is levee flood risk analysis and its various steps. First, we have risk identification, detailed in section 5.2.3. To analyze risk, first the factors affecting risk must be recognized and recorded to identify what might happen and what situations may arise. These factors include the source pathways and receptors of the flood system. Then we have loading event probability estimation. As floods and storms are episodic events, and large floods are rarer than medium-sized or so small floods, the probability of each size of event can be characterized as the chance that it will occur in any 1 year in terms of its annual probability. Then we have the analysis of levee failure. The flood risk in a levee area depends on the performance of the levee system. Where a failure in the levee system occurs will partly determine the receptors of impacted by inundation. So how and where a levee system might fail is important in estimating the level of risk. This activity is directly related to the assessment of the performance of the levee during a flood, which is the matter of section 5.3. In risk analysis, the result should be expressed in probabilistic terms. Inundation modeling, described in section 5.2.6, in order to assess potential damage or to prepare evacuation plans, information is needed on inundation patterns, including water depths, flow velocities, and timing of inundation. This information can be obtained from inundation models, computer programs that simulate inundation along rivers, coasts, or even urban drainage systems. Consequence estimation is a measurement of the consequences which are the harm to the receptors exposed to inundation, and may be a direct and indirect result of flooding. An analysis of an evaluation of the likely consequences of the flood event needs to be estimated in order to determine the potential magnitude of the impacts of the flood event. Finally, the estimation of the level of risk is the actual result of the flood risk analysis. It is an estimation of the level of flood risk calculated by taking into account the probability of a flood event occurring and the potential consequences of that event derived from the previous step. This is detailed in 5.2. Other activities like effectiveness of existing controls have to be taken into account. Controls are structural or non-structural, taken in order to limit the possibility of occurrence of an inundation or its consequences. They can apply to either the source, for instance breakwaters, to the pathway, for instance levee maintenance, monitoring and emergency management, or receptor, for instance flood warning, population and evacuation. Existing controls can and should be taken into account in the estimation of the event probability of the levee failure and in the consequences of the inundation. Risk attribution and risk evaluation are further steps to the process. Risk attribution is a method of attributing the residual risk in the levee area to individual levee segments following the previous risk analysis methods and allows prioritization of investment between levee segments. Risk evaluation is not strictly a part of a levee manager's risk analysis, as commonly agreed benchmarks for flood risk acceptability are not always available, and it is a broader society that dictates the technological community the acceptability or tolerability of the levels of risk, as it does for many other risks to society. Communicating the evaluation to decision makers is important to allow them to determine whether or not to proceed further with risk reduction measures. This figure presents example of results from a flood risk analysis of a levee system, although the data used here was hypothetical for research and presentation purposes and is not actual data. The figure on the left presents the probability of inundation of a floodable area. The figure on the right presents the expected annual damage of the same area, which is a combination of the probability of flooding with associated consequences, probabilized in terms of annual damage. also could have presented associated maps of Levee's probability of failure and associated risk attributed to Levee segments, which are also produced in this type of analysis. Section 5.3 presents the principles of performance assessment of Levee or Levee systems. The place and level of detail of the different types of assessment in the Levee management cycle, the importance of the analysis of failure modes, different types of assessment methods, including the typology of data, data processing, and nature of results, illustrated by some examples, the reporting of assessments, and the links with regulations. A good understanding of the Levee, of its behavior, and of its relative vulnerability for different failure mechanisms during flood conditions will assist in directing inspections and what specific features to look for and where, in the diagnosis of observed features, that is, identification of the cause or nature of a defect or element of deterioration of Levee, and this relates to failure modes and processes, in the prognosis of the performance of the Levee during potential future flood events, and in the need to take emergency measures and which measures. A complete assessment should always include a diagnosis of the actual or possible causes of failure in order to remediate or prevent them. This means that all potential failure modes for the Levee and their relative importance to the overall performance have to be determined. The outcome of a Levee performance assessment will be, in final, prediction of how the global Levee system and the individual Levee segments will perform under a range of loading events. Levee performance assessments results are related to its main function, which is to protect against flooding, and to its resistance to structural failure modes. There are different possible forms of results for Levee performance assessments, such as a threshold, which is a limit load, or the conditional chance of failure for a given load, or a fragility curve, which is a conditional chance of failure given for a range of loads, see the figure on the right, or a safety factor, or an index, examples on 0 to 5 or 0 to 10 scale, or even qualitative descriptors, example, a choice between very good, good, fair, poor, very poor. The form of the result depends not only on the data processing method used, but also on the way it will be used thereafter. It is possible to make comparisons between the different types of results, and possibly to transform a result of one type into another type. Assessments should take into account all available data related to the different possible failure modes. Different types of models can be used to combine data. Actual models, using both physical or empirical based equations, index-based methods, using predefined combination of index rating of different observations or parameters, expert judgment, direct, or using one or more of the above method types as preprocessed data. This figure presents various types of assessment in the Levee life cycle and the ways I use previous assessment. The left part presents the initial assessment and rehabilitation of an old Levee system with previous poor maintenance. In the central part are the regular assessments in the frame of the Levee management life cycle. The right part includes specific assessments in the frame, the right part includes specific assessments and interventions, for instance, related to a flood event or related to the detection of a particular problem on the Levee system. The color code is as follows. Yellow indicates inspections, green indicates other data sources, purple indicates assessments, diagnosis, and risk analysis, and blue represent works in terms of maintenance, rehabilitation, or repair. Inspections are the most frequent data gathering method used in Levee assessment. Inspections are either part of a wider assessment process. In this case, they are a data gathering process among others, or they are a specific operation from the Levee manager. In this case, an inspection is the simplest type of assessment, in the sense that conclusions and decisions can and must be made at the end of the inspection process. Section 5.4 of the International Levee Handbook presents the purpose and principle of inspections, the place of inspections in the assessment process, the different types of inspections and the different occasions for inspections, inspection management, and the conduct, reporting, and follow-ups of inspections. Inspections can and have to be conducted in normal conditions as well as immediately after loading events, river floods or sea storms, if it is safe to do so. Inspections need to be prepared in advance, both in terms of staff, availability and training, of equipment, for instance, GPS, camera, specific forms, in terms of safety, in terms of list of features to inspect and destroy, of condition grading, and of reporting methods. The table in the handbook, an excerpt can be seen in the illustration, presents the common visual indicators, example of condition grading, the associated mechanisms and failure modes for both earthen levees, components of levees, structure associated with levees, and transitions with floor walls. Another table lists a more complete list of items to be inspected during an inspection. Specific tables for given situations are built from these tables with the inspection program. Section 5.5 presents different types of data acquisition activities, which, in addition to inspections detailed in previous section, are very important in detailed assessments. Investigations, which are conducted on a one-time basis in a specific process. Monitoring, including the use of instrumentation, which consists in repeated measurements or observations. Monitoring measurements have to be analyzed. Section 5.5 also presents principles for planning investigations during an assessment process according to the type of assessment and its objective and the data that is already available. The detailed presentation of the different types of investigations and instrumentation methods is not covered in Chapter 5, but is covered mainly in Chapter 7 and partly in Chapter 8. Investigations can be conducted in a phased approach, which is explained in this section in order to refine the program and function of available results. This is usually necessary as levees are usually long and can be heterogeneous and need lots of investigations in order to be well characterized. An example of phased approach is presented in the figure on this slide. The link between the different types of test results and measurements and the various failure modes and mechanisms has to be made in order to conduct assessments. Some tables in this section, such as the two excerpts shown here, explain this approach and give some examples of the more common data and failure modes. Of the analysis of monitoring data is presented. Levee-related data is the heart of any assessment process. It is also essential for all management and design activities. Data also has a cost. So data has to be properly managed in order to be preserved, but also to be easily accessible during all assessment, including during emergencies such as a flood or storm event. Section 5.6 presents in a table the various sources, natures, and types of data, as well as their purpose, and explains all these concepts. This section also justifies the need for data management and presents the principle of information systems, including paper and digital media. Specific information is given in the design of computer-based systems, databases, and GIS. The design of Levee-related data management and information systems is a complex task, but it is absolutely necessary in order for the system to fulfill the needs of the Levee management. The data model is the most critical step in this design. It should include the analysis of the different data processes. The picture presents an example of a data model. It is hardly legible on the screen, but its purpose is just to give an idea of the complexity of Levee data systems, and so of the necessity of conducting a good and complete analysis of the data model before starting the development of the information system. In addition to the strict data management, automated processes can include tools to help assessment and risk analysis and enhance the presentation of the results. Examples of these are presented in various parts of the chapter. In conclusion to Chapter 5, assessment and risk analysis are conducted in a progressive, tiered, and phased approaches, all along existing Levee's life cycle. The results are essential tools for helping decision-making for both Levee management and design of improvement. The flowchart on the next slide proposes a logical process linking assessment and risk analysis to decision-making. This flowchart, based on the result of assessment starting from the input data here on the left part, which can be visual inspection reports of all types, including routine, periodic, and during and post-flood, instrumentation and monitoring data, investigation results, and various other types of data. According to the assessment result, including its uncertainties, the result of in terms of hydraulic performance of the system, the structural performance of the system, it can be decided to initiate new assessment, including possible new data gathering, to design a new system with new protection objectives, to improve the safety performance level either by major works, emergency action, or maintenance repairs, or do nothing special and stay inside the regular Levee management life cycle. These emergency actions can be intensification of the frequency of observations, Levee reinforcement works, appointment of expert engineers, or inform authorities in charge of population safety of a possible Levee failure and subsequent inundation. Thank you for listening to this presentation. I hope it has given you a flavor of the coverage of Chapter 5 and encourages you to investigate the other chapters of the International Levee Handbook, which each have similar presentations. The complete handbook can be downloaded from the Syria website, the link to which is given on the current slide.